going to do this best that we can here. Okay, so we're going to make a graph of the data that we took down yesterday in the Circle Lab. Okay? Now, what type of graphs have you guys worked with before? Bar graphs, pie graphs, line graphs. Okay? All right. A Venn diagram is not exactly a graph, because a graph is supposed to be able to all right, please listen. A graph is supposed to show numerical data, so basically measurements, in a visual format. Okay, so a Venn diagram is just a way of organizing thoughts. So yeah, those are all different types of graphs. Okay, now the main types, you guys already came up with are line graphs, pie charts, and bar graphs. What do you think would be the most useful for this data? You think? A circle. You like the irony there, don't you? If we do a circle graph of the Circle Lab. Well, what's a pie chart good for? Like percent. Yeah, percentages, right? Do we have any percentages here? Nah. So that's probably not very good. What about a bar chart? What about a bar graph? What's that good for? That's good for this. You think? Yeah, measuring like quantity. Measuring quantity, and maybe. Right, we want to be able to compare things right next to each other, right? Now here's the thing, okay? If we were going to look at each of the circles and compare their circumferences or compare their diameters, right, then a bar graph might be useful, right? But that's not what we're going to do. What we want to do is we want to look how one measurement relates to another, okay? We want to look at how the circumference is related to the diameter. And when you are comparing two different measurements to each other, when we're looking at how two measurements are related to each other, a line graph is going to be the most useful. So, actually, why don't we summarize that a little bit here? I'm going to put up a new thing here. Forgot I can't use those markers. Here. We'll type it out so that it shows up. So this would be good stuff to write down. So like you guys told me, a pie chart is good for percentages. A bar graph, we said, was good for comparing a single measurement. Let's say compare single measurements. Oops. Should probably spell measurement right. But then what did we say a line graph is good for? Comparing how two measurements relate to each other. So compare how two measurements relate. Okay. Now today we're actually going to be working with a subset of line graphs, a special type of a line graph called a scatter plot. And a scatter plot is basically a line graph, but you don't put the lines on. So you don't connect each of the dots that you put on there with your lines. You just leave the dots where they are. And we'll see why tomorrow when we start looking at best fit lines. Okay? So a scatter plot's not a completely different type of graph than a line graph. You still use it for the same thing. It's just here we're not drawing the lines in between each of the things. All right, so you guys already know what a scatter plot is then. For the most part. Okay. All right, let's go back to this. So here we see the axis of a graph, right? And a lot of times in math they like to call this the y-axis and this the x-axis. And that's fine, but there's a problem with that when we get to physics. We tend to actually measure something called position, and the symbol for position is x. And so it gets kind of confusing to say graph x on the y-axis. People get, ugh. So I like to refer to these as the vertical axis and the horizontal axis. Okay, vertical means up and down, horizontal means side to side. So we're going to refer to them that way. So vertical, and this is the horizontal. Yeah. What's that? Are you supposed to draw this? You can. It's not too hard just to draw L there and label it vertical and horizontal. Now, there are three things that every graph should have. Okay, number one, every graph should have a scale. And the scale is basically the numbers that you put on each axis so that you know how much of a measurement there is. Okay? So the scale is the numbers on each axis. If you don't have those numbers on each axis, I mean, it's pretty hard. You can sort of look at relationships between things, but it's pretty hard to tell what you're actually looking at because you don't know if this dot is at 10 or 100 or 5,000. Okay, the second thing that all graphs should have are labels. Labels tell you what was measured and the units used. What do I mean by units? Like centimeters or inches or whatever. Okay, just like yesterday I looked at a couple of you guys' tables and I was like, well, there's no units on here. I don't know what, is this in miles? Is it in kilometers? Is it in inches? Is it in centimeters? On your graphs, you have to show that too. So whatever we put down here, we need to say what we're measuring and what units were used. Whatever we put right here, we need to say what we're measuring and what units are used. Okay, and then finally, every graph should have a title. And a title should be a description of what was measured. Okay, now, I went around and looked at your titles for homework, and none of them were bad, but some of them were better than others as far as descriptiveness of it. So, for example, if you just put circumference and diameter, okay, but circumference and diameter of what? So you want to actually be descriptive, and I think, what's your name? Sorry. Emily. I think Emily had a pretty good one. There's other people that did, but I just remember looking at hers. What was the title that you put down? Okay, circumference and diameter of different size circles. So see how she had there what we're actually measuring, different size circles. Okay, so somebody can look at the title of that graph and go, oh, I know what was measured here. Okay, so it shouldn't be vague. It shouldn't be unknown what the experiment was actually doing when you look at the title. So that's something that can be a little bit hard. I mean, that's one of the things that the chemistry students struggle with the most on their labs, is coming up with a good title. But every graph, no matter what, no matter if it's a line graph or a pie chart or a bar graph, should have those three things. Okay? Your graph is incomplete if it does not. Any questions there? All right. Now let's get to the actual thing that you guys are going to do. That's enough with taking notes today. Let me actually clone this. Well, I'll just make a new one. Okay, here I've got some graph paper. Now, I'm not going to take the time to go and do, all the lines on here, but, graph paper is usually split up, into all those different boxes. What you guys are going to be doing is you're going to be making a graph of your data, but we want to make sure we put things in the right spot. On the vertical axis right here, we're going to do circumference. So, let me write that. On the horizontal axis, we're going to do the diameter. Okay. Now, what's the first thing you kind of have to figure out before you start making your graph? The stuff. Very vague. Labels and title, you can put those down. But you got to figure out your scale, right? Okay? If you make every box worth 1 inch, maybe that's going to squish the thing down too much. Maybe it's going to be too far and your data is not going to fit on. What you have to look at is kind of the range, right? What is your smallest unit and what is your biggest unit? So you got to kind of determine how many boxes are across there, make sure it'll fit in there. Maybe you want to count by 2s. Maybe you want to go by 3s. It just depends on your data. Okay? Does this axis and this axis have to be the same? No. You can go by 2s down here and by 5s right here. There's nothing wrong with that. The thing you have to be careful of is you got to make sure that it's the same. You can't go up one box and put 5 and then up another box and put 6. Okay? If you start going by 5s, you got to go by 5s all the way. If you start going by 3s, you got to go by 3s all the way. Now, I know, yeah, in math, sometimes they'll do this, right? You put this kind of little thing right there, and you'll start at like 100, and then you can do 101. Because of the way we're going to do graphs, that's not going to work for us, okay? There are some ways to get around that, but that's kind of farther on down the road. So for us, we don't ever want to skip there. We want to start at 0 and go up by the same amount the whole time. Okay, any questions there? So our goal for the rest of class, I'm going to hand out this graph paper, figure out your scale and label it, okay? Graph your data, and then make sure you put all the parts of the graph, your labels for your what's being measured and your units, and then a title. And try to get a good descriptive title. I'm sure all of you will just copy what Emily put, but we'll get better at coming up with our own titles as we go on. Okay? So, let's just be clear. When you are going to graph the data for a circle, right? Jared, what was one of your circles? Yeah.
Which one do you want?
Both.
One was circumference is 15
4 and our circumference was 15. So what I would want to do is I would want to go over to 4 on the diameter, wherever that is. So say that's 4 right there. And then I would want to go up to wherever 15 is on the circumference, and I'm going to put a dot. So that is the data for one circle. This dot, is what was that? Did you number or name your circles? Numbered them. So what was that number? This is number 1. Okay, and you can actually next to the dots put the label number 1. What was number 2? I'll get you a question in a minute. So the diameter was 10. Okay, so you go over to wherever 10 is, and then what was the circumference? 3? Oh. Sure about that? You sure those aren't backwards? Okay. So over to 3, and then up to 10, and this would be number 2. Okay? All right, question. Do you have to what? No. Remember, we're doing a scatter plot, so we're not going to connect the dots, right? All right, I think we're hopefully to a point where we can get started on this. If you have any questions, I will be walking around to help you. You're going to do it on this graph paper right here. Eventually. Now, you guys have your data. You don't have to get together with your groups, but if you'd like to, that's fine. I don't really care. But everybody does need to do the graph. You don't have to. No, just space it out so it's not too crammed together. I don't know if you want one of those or not. Now remember, you want to look at your biggest measurements so you can figure out, kind of how far out you're going to go on your scale. Figuring out the scale is one of the harder parts. Yeah, and you don't have to use the side of the paper. I know there's kind of some words down there. If you'd like to redraw an axis a little bit, that's fine too. I would say you want to spread it out so you're using at least half of the graph. If it's more compacted than that, everything's going to be crammed together. Oh, also, make it easy on yourself. You don't have to label every single line. I would label at least every other. So if you're going by 5s, go up 2 and put 10, go up 2 more and put 20. You don't have to label every line. We can still read it if you go every other one. All right, so you want to... Not exactly sure what's going on here.
Doing what you said, and these centimeters because I have.
Well, how come why are you drawing these lines here?
Because I'm skipping these ones in between because they're too small.
Well, that's fine, but you don't. I don't know. You don't draw those out. You just label along the axis because we're going to put dots.
No, I was just going to make it clear.
Do you see what I'm saying? Yeah, but I think that's going to actually make it more unclear if you got all these extra lines on there. Yeah, so on the in-betweens, you're going to have to kind of guess. I would say probably, I would make each line at least 0.5. You could go 0.25. That's kind of up to you, but I would go at least 0.5 for every line there. Oops. Okay, yeah. All right, let's talk about this, Nolan. Yeah, you don't want to go by the measurements that you have here, right? And we're going to do circumference on this side, right? Okay. So here it looks like, what, your biggest one is like 9 inches.
Or the 2 feet.
Oh, 2 feet, yes. Okay. See, that threw me off. You know, mixing your units like that can be a little bit hard because it throws you off. So 2 feet, you're probably going to want to put that into inches. So that's going to be like 26 inches. Okay. So I would probably go up 26 by 2s here. So I would make this 2, and this one's 4, and 6, and 8. Do you see what I'm saying?
This one's 2.
I think that's going to spread out too much. I think that one would be 4.
You want this one to be 2 and this one to be 2?
No, not the bottom one. This one will be 2. This one will be 4, 6, 8. Keep going that way, okay? You can put their names on. That's fine. I mean, it's kind of up to you if you'd rather put numbers because you feel like it'll be neater. That's fine. How you doing, Isabel? How are you doing? Feel good about this, or need some help? Okay. 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 Yeah, I think that looks good. I think, you know, looking at this, I think you could have expanded a little bit more, but I think it's fine. I'd stay with that. Okay. That looks good. Now, what about the diameter side? I don't think you have to, because you can kind of just, you know.
Probably just the 1 and then do this.
Well, one might be a little too close together. I would maybe do this to be 0.25, so a quarter, right? So a quarter, a half, 3/4, 1.
So this one, 1, 2. This one would be 1.
Right.
And this one would be like 50.
Yeah. Well, 0.5. Okay. And then keep going over like that.
I'll have to make it clear.
Yeah, I think you get a little smashed together, but that's all right. Don't change it. I think you're fine. So you got a title, and you got your labels here. Okay. One thing we're missing though. Oh, you got inches there. All right, that's cool. That'll work. Just like with the table. One thing you can do is you can just put the label right here, and then you don't have to put it behind every single number.
Oh, okay.
Okay? It's just a kind of a hint. Well, just hold on to it. Hold on to it. Okay, so what are the 3 things that all graphs should have? Okay, we got that. What was measured, but we also have to have units, right? Let's make sure you put your units on your axis. Yeah, you just put behind here what is measured in circumference. In what? What did you measure in? Okay, cool. I like it. So now we got labels, and then what's the last thing it needs to have? Title. Okay, that looks good. I like it. Yeah, and as you finish up and I come around to look at yours, I'm going to be looking to see if your graph has all three things that we said every graph needs to have. So you might want to look back at that list.
Good.
Okay. So we got our date on there. All right. What are the 3 things that every graph should have?
The vertical,
scale. So you got your scale, right? That's good. All right, what else? Labels, what's measured and the units being used. So we don't.
I gotta put like centimeters or something.
Yeah, if it was measured in centimeters, yeah. If you got centimeters, yeah, just put put in centimeters or put centimeters in parentheses. That's cool.
I think my graph is very big.
Hey, bigger graphs are always better. And then a title, good.
From our so here, do you put all of them or each one?
Oh, I just thought about that.
We got like 30.
Okay, looks pretty good.
Kind of in between. 5 and 6 is in between.
Well, okay, yeah, just do the best you can.
So I just kind of put them.
Yeah, good, great, keep going.
And I wear every
Oof! Look how close they are together. Yeah, so we maybe should have expanded this a little bit and only went by like ones or something there.
like 5.
Yeah. So that'll work though. All right. There's one thing you're missing here. Remember, on the labels, you have to have the units as well, right? So we need to put down here on each side what the units were being measured, if they were inches or centimeters or whatever.
I always creep on
Okay, here for your title, I'd be a little more descriptive because you measured more than just circumference, right? Right, so measurements of circumference and diameter. And what did you measure? A bunch of circles, so put that down. Be descriptive. Yeah. Yeah, no, that looks pretty good. Remember, we want to be descriptive here, right? Circumference and diameter graph. But what did we measure the circumference of circles, right? So put down. And if you really wanted to be descriptive, what would be really awesome is if in your title you told us how many circles that you measured.
What kind of bird is that? I know what kind of bird it is, do you?
Oh, is it a killdeer? It's hard to tell sitting down. There's actually a bunch of different plovers that look like that. That would have been my first guess. Oh, I don't know about that. that was a compliment. I think you're pretty quick. Yeah. No, you'll hang on to it. We're going to use it tomorrow too. Yeah, pretty good. Yeah, Jared looks pretty good. Jared has the best title out of everybody. Huh? You don't? Didn't you add what I asked you to? Oh, well then you have the best title out of everybody. 3. Okay. I think most people are done, or at least finishing up a little bit. Jared, what's your title? Of 5 circles. Now check out how descriptive that is. Okay? All right, hey, listen better than that. You missed Jared's title. It's the best title I've ever heard. Well, here's the thing. Why is that so good that he put the number of circles on there? Because different groups actually had a different number of circles. And so just from reading the title, we know, okay, Jared measured 5. If Nolan put that down, we'd know he measured 6, right? So that's even more descriptive. So remember, we want to put as much information into our title as we can. Now, we're probably going to overshoot, right? You guys are going to start putting more and more descriptive stuff in there. We might get to a point where we go, okay, we don't need to know that. But I would rather that than, it to be very, very vague. So let's kind of work towards that. All right. I got one more thing to explain here so that you can do your homework, and then we'll be pretty much done. And that is the concept of something called a best fit line. Have you ever heard of a best fit line? Never? All right. Let me explain how to draw a best fit line. Okay? All right, listen up, please. A best fit line is a perfectly straight line. It does not bend anywhere. So this isn't like the lines on a line graph where you would go and you would connect every one of these and it just kind of go all over the place. A best fit line is perfectly straight. To draw a best fit line, you really need to use a straight edge. And apparently, I put all of my meter sticks back. So just a minute, let me grab this. You can't draw a best fit line freehand. It just does not work. So whether you use a ruler or the side of your phone or the side of a driver's license. Oh, you guys don't have driver's licenses yet. What you want to do is you want to put it on, okay? And what you have to do is you have to try, and this is the hard part, so pay attention. You have to try to put your straight edge on in a way that it comes as close to all of the points as possible. And that can be a little bit hard. So you kind of have to, it's a little bit of judging, right? But you kind of have to go, okay, it doesn't have to go through. In fact, a best fit line doesn't have to go through any of the points. So don't try to cram it through one of the points. But we want to just go to a place where it kind of looks like it averages and goes between as many of the points as possible. So I would say something like that. And then you draw your best fit line, and you always want to draw it. We should actually extend this. My meter stick is not long. Out past the data on one side, and you always want to draw it so it hits the axis over here. You always want to draw it so it hits the vertical axis. Sometimes your best fit line may dip down below the axis. That's fine. Okay, if you drew a best fit line and it came down like this, we want to make sure we extend over to where it would hit the axis, because that's going to be an important point for us. Okay? So best fit lines, perfectly straight. Go as close to all of the dots that you have as possible, and you need to make sure it hits the vertical axis. Guess what your homework is? Draw a best fit line on your graph. Okay? You have to use a straight edge. There's lots of things that you can use for that. And you have time to get this done right now, so you don't have to do it while I'm walking over to stamp your paper.
I've only got